Hey, what's going on guys, KIM-1 here. In this video I'd like to introduce a new KIM-1 emulator I made based on Arduino. This time this is Arduino MEGA with the TFT display. So whatever goes to serial port is being displayed here on the display. So let's kickstart by resetting and having a look at the nice demo in the beginning. Alright, so we are getting directly into the KIM monitor. Nothing special so far, but if we go to 9548 and space and shift G, in this case we're getting into the supermon plus 64 by Jim Butterfield, which is the hex monitor for Commodore 64, and I made a port of that hex monitor to KIM-1. So let's inspect the memory at the address 300s. So you see, like, it's kind of empty there. So we can assemble LDA. So for instance, to the A register, we load 1. Okay, now LDY to Y register, we load 2. And LDX to X register, let's load 3. And we're done. Now we can disassemble this from 300s to 300s and A, for instance. It's a little bit too much, but yeah, it's okay. So just assemble 3 lines. You know, let's say if I say go to 300s, it would now put the program counter at 300s and execute the code there. And I'm back into the KIM monitor, obviously, because that's where I'm getting after the interrupt, right? So in order to get back, I can say 9548 and shift G again, and now inspect the registers again. Now you see, like this. This is 0803, but this is actually the little endian, so it should be read like 0308, and that's exactly where our program has stopped. And you have a look at the registers. So you have this A equals 1, Y equals 2, and X equals to 3, exactly as we asked this to do. But actually I could have used fill from 300s to, let's say, 30A, like FF, for instance, and memory 300s. Okay. Yeah, but I can say F from 300s to 30A, and now zeros. And 300s. Yeah, no, this is fine. Okay, so now let's write another simple program. So for instance, I'm going to assembly 0300, and I want to say jump to subroutine 1E5E. This would take user input from the serial port. And then I just want to jump to 300s. Okay, so doing this in the infinite loop. So let's disassemble 300s and 8, for instance. Okay. And if I say go to 300s, okay. So here I'm capable of, so here is just a program being executed. Once I press escape, a non-maskable interrupt triggers, and I'm back to the KIM monitor. So far so good. So what else is available here? So also quite an interesting thing to consider is here I actually have basic by Tom Pittman, tiny basic by Tom Pittman. So if I go to 2000s and Shift G, then we are in the basic territory. So for instance, 10, let's say n equals to 10, all right, 20, I want to print n, then 30 n equals n minus 1. Okay, then 40, say if, and this tiny basic doesn't have the for loop, hence I'm forced to use the goto here. But anyways, so if n is greater than 0, it's greater than 0, yes, I want go to 20, right? Yes, exactly. Okay, so let's list our program. Got our program here. Epic. Awesome. And just run. Yeah, and the basic program executes. What a beauty it is. We got an error here, and that's because I forgot to put the end statement at the end. So let's have a look at the list. So I need to say 50 and end, and let's list again. Okay. Now let's run. Okay, and we got the execution being done. But what about loading and saving your work? So for instance, let's, there are a couple of ways to drop away from basic. I could have called some user subroutine and a given address where I'm sure there is a 0, like, just to give you an idea, like for instance, if I say a equals to user routine and maybe 2, there should be 0. I can store the entire 4K of RAM. Only 4K can be stored to EEPROM, so press enter. Okay, this hopefully should save the data. Okay, now it saves the data. Now the EEPROM starts 2900 to 38FF. So let's inspect these values just to make sure that we actually didn't manage to write something there. So 2900 should be containing the value of 300s, and indeed it does. It has 12. And here I simply say user and load. So this L and S are just the variables that they are kind of predefined in on start of the emulator. So there the value is getting written to the RAM on start. And enter. So now it loads the memory and it's done. Enough. So we've already loaded the chunk of 4K from EEPROM to RAM. And if I go to 300s, then we have this value of 12 that was there. Idea is that the chunk of memory is being loaded, which is really good news. So you might be wondering that this is kind of it, but well, actually this is not. I'll now demonstrate how I can upload the paper tape. I have my 6502 chess paper tapes. This looks like just a paper tape format. 3 files from 0 page, from page 100, and from 200. Shift L, and now KIM-1 is waiting for a paper tape to start coming in. So we drop back here, and this is the first chunk, and let's go. Okay, and now the data is being loaded. here, and here it's receiving. So it's right in here. Okay, and here it's receiving the data. Well, the layout is not that great, and because of the line wrapping, it just wraps the lines because it doesn't fit really. Yeah, no errors, which is good. Want to go for the second file. Okay, and the second file has been loaded. So yeah, it's now loading the second file. It's quite slow because if you do this faster, well, actually, KIM-ROM won't understand if this goes faster. And also the serial port, yeah, obviously has some limitations. Okay, finally we are done. And now, one of the cool things to demonstrate is it doesn't have a game loop. You can just call some functions to interact with this. So for instance, if I say 03 F6, I have a print board function there. And if I say space and shift G, then it prints the current board state. So 08 on the right means it's white to move, and otherwise we have the board position. In order to make the move, you need to alter the memory. So starting from here, we have 0, 1, 2, 3, 4, 5, 61, 2, 3, 4. So 64, if I go to 0064, yes, there is a pawn. So for instance, here I erase the pawn like this, and now I go to 0044 and put 09 there. All right, and also go into 00BC, whereas the color, decide to move, and switch it to 10, which means black. And if I go to 03 F6, again, 03 F6, and shift G. So I just made a move, as you can see here, and I've changed the site. So now I can ask the engine to go. So if I go to 0 to 1, this is the surge depth. So at the surge depth 3, that's the minimal surge depth where you can find the mate in 1. In order to find mate in 2, you need to deepen the depth, but it's slow as hell, so it's impractical to wait like for half a day until it's done. So I would rather say, let's give it like 02, or even 01. Let's even give this 1, because I don't want this to last forever, really. Okay. All right, and now go into 200s. So here the search routine starts. Let's do it like this. 200s and shift G, and now the engine is searching, and it found a best move in this position. So you see, like, it plays the Scandinavian defense, I guess this is called. So D7 to D5, and so on. But I can actually, instead of playing myself, I can ask the engine to play versus itself, because it's kind of too long to move the pieces all on the way. So if I go to 200s again and shift G, then yeah, then pawn takes, and then I believe queen takes. Just to make sure that the board layout is okay. So 200s, shift G. Okay. Yeah, queen takes. So then knight c3 should be on the cards. Yeah, let's have a look at one last move. Okay, 200s, shift G. Actually no. Actually pawn goes to d4. That's quite an interesting move. Yeah, but assuming the depth of 1, yeah, it's actually doesn't make that much sense. Well, anyways, guys, it's not about chess. It's about emulating the good old KIM-1. And I hope you enjoyed the video. The source code, the firmware for this emulator will be available in the description below. And all you need to build this on your own is just Arduino MEGA and this nice TFT Shield. So just to give you an idea, so just have the Arduino MEGA here. Right, you can't see this, but trust me, this is Arduino MEGA, and this TFT Shield just being plugged in like this, and that's it. And I have a nice spot here to put it here. So this is it from my side. Thanks for watching. Until the next time, and take care.